Good morning everyone, this is your teacher Sir Tony Falcon. Today we are going to discuss another important gas law, and that is Boyle's Law. Why is Boyle's Law important? It is important because it tells us about the behavior of gases. It explains with certainty that the pressure and volume of gas are inversely proportional to one another. But we are not just going to define it, we are going to prove it mathematically, and we are going to give some practical application in real life situation. So, come, let us join me in discussing Boyle's Law. This is the formula we are going to prove the relationship between pressure and volume. And it states P1 V1 is equals to P2 V2. And another thing, I have here an example of worded problem which we are going to solve to show the relationship between pressure and volume. A scuba diver needs a diving tank in order to provide breathing gas while he is underwater. How much pressure is needed for 6 liters of gas at 1.01 atm to be compressed in a 3-liter cylinder? Now, what do we have here? We have 6 liters, and that is volume. And 1.01 atm, that is temperature. And another one, we have another volume here, which is 3.00 liter. We are going to prove this using mathematical computation to show the relationship between P, which is pressure, and V, which is volume. To solve a worded problem in gas law, the first thing you need to do is to find what are the given. Now, in our worded problems, here are the given. We have volume 1, which is 6.0 liter, volume 2, 3.0 liter, pressure 1, which is 1.01 atm, and pressure 2 is the unknown. Another thing, after getting what are the unknowns, we need to identify now what formula are we going to use. And since we are looking for P2, we need to have the formula in looking for the pressure 2. We are going to get the formula for pressure 2 by manipulating the general formula, which is P1 V1 is equals to P2 V2. Okay. To identify the formula for P2, we need to eliminate volume 2. And to do that, we divide it by volume 2, and then we also divide it volume 2. Eliminating volume 2, we will get the formula for P2 is equals to P1 V1 over P2. So this is now the formula we are going to use in order to get the value of P2. This is now the final formula for P2. Then we are going to put now the values for its variables. For P1, we have 1.01 atm. For V1, okay, we have 6.00 liter divided by V2, which is 3.00 liter. You multiply 1.01 atm to 6.00 liter divided by 3.00 liter, eliminate liter, and we will have 2.02 atm. So this is now the value of our pressure 2. Okay. 2.02 atm. This is how we get the pressure for pressure 2, which is 2.02 atm. So after a series of computation, okay, in Boyle's Law, we now have the following value. Okay. Volume 1, initially, it's 6 liter and it becomes 3 liters in volume 2. Initially, we have pressure 1.01 atm, and through computation, we now have 2.02 atm. So what is the relationship between two variables, which is P and V? Pressure and volume relationship in Boyle's law. Okay, this is 1.01. So what happens? Pressure goes up. Initially, 6 liter. What happens to the volume, the final volume? It goes down. So pressure and volume in Boyle's law are inversely proportional. When the other variables goes down, the other variables goes up. Or when the other variables goes up, the other variables goes down. Okay, so I hope you learned something from our discussion today, which is Boyle's law. Now we are going to apply it in real life situation. You may have wondered how Boyle's law is applied in real life situation. You can observe a real life application of Boyle's law when you fill your bike tires with air. When you pump air into a tire, the gas molecules inside the tire get compressed and packed closer together. This increases the pressure of the gas and it starts to push against the walls of the tire. Soda bottles or cans are another practical applications of Boyle's law, but unintentionally. Note that when you open the bottle of soda, the gas rushes from everywhere. When you open the bottle, you are actually reducing the pressure on the gas and the volume of the gas expands. I hope you learned something from our discussion today. And if you like our video, please don't forget to subscribe, like, and share it so that others will learn from it. Thank you for watching.